Everyone. So today's topic is going to be written work, and this part again comes under the broader umbrella of quants, that is arithmetic section. Uh, Very important topics because uh, the questions will be asked definitely in almost every exam basis written work. So today in our agenda, we are going to see what are the concepts that are related to written work and what are the different types of questions that are related to written work, and we are going to solve them using different approaches. Along with written work, we'll also see one small part, which is something called as pipes and systems. Now, pipes and systems is also included in the written work because there are a lot of similarities between them, and the question solving style also kind of remains the same, more or less. So that's the reason they both are normally clubbed together. So, with that being said, let's move on to the idea that what is work done or what is the formula for work done. So, very simply, work done is defined, or we can say work done can be described based on three parameters. One of the parameter is how many people you have or how many workers you have. The second parameter is that uh, for how many number of hours they are working, the machines or the people that you have. And the third part is, of course, how much time they take to complete the work, which can be also called as number of days taken to finish the work, basically. So that's a broader formula. The same formula can be rewritten something like this also, which is a number of people slash machines into rate into time. So this hours per day part is also called as rate at which they are working. At what rate they are working, whether they are working 5 hours per day, 10 hours per day, 8 hours per day, whatever may be the case. And number of days can be also called as time taken to complete the work, time taken to finish the work, basically. So that's the formula, and this is the only formula that is there for work done, basically. Now, basis this formula only, we have to see certain relationships, and that is very commonsensical. So it is not something that is super difficult. So the first relationship is between rate and time. How basically they are connected. Now, logically speaking, we just saw a bit ago, few moments ago, that rate is defined as how many hours per day the workers are working, and time is basically number of days that the workers are working. Now, try and think about it logically. What do you think should be the relationship between these two? So obviously, they both should be inversely proportional. Why inversely proportional? Let me give you an example. So suppose the earlier workers are working, let's say 6 hours per day, and they are taking, suppose example, 8 days to complete the work. Now, if I, let's say, ask them to work for 8 hours per day instead of 6 hours per day, if I ask them to work for 8 hours per day, obviously you can understand that the work will be done earlier, the work will be done faster. That means time taken reduces. So if I increase the rate, time reduces, and vice versa. If I slow down the workers, time will be more. The job will be delayed for the completion. So both are inversely proportional. One increases, other decreases, and vice versa. So that's the one thing. The second thing, that is number of people and time, how they are connected, basically. So number of people and time, again, I feel they are commonsensically, if you think, they are also inversely proportional to each other. The logic is pretty much the same. Let's say initially five workers are working and they are taking 8 days to complete the job. Now, if I put on 10 workers, so obviously, if I double the number of workers, time should be ideally reduced, provided their frequency of working or the rate is same, basically. So obviously, if I increase the workers, time will be less. If I reduce the workers, time will be more. So again, these two are also inversely proportional. Number of people slash machines is inversely proportional to time. Now, once these relationships have been established, we can find out the ratio, and it is again based on the same factors. So, just say for example, they have given a rate of two people, which is in the ratio A is to B, for example, and we have to find out two things. One of the thing is time taken for two of them to complete the piece of work, and the second one is work done. Now again, just now we saw some time ago that rate and time are inversely proportional. So obviously the ratio should also be inversed. So if the ratio of rate is A is to B, the ratio of time will be inverse of that, which is B is to A, for example. And then we have to also find out work done ka ratio. Now for this, we need to find out the relationship between rate and work done that we have not explored so far. So simple logic, rate and work done are directly proportional. Why they are directly proportional? Let's try and think about this. So rate is defined as how many hours per day the workers are working, right? Now think about it. If I increase this hours per day wala calculation for every worker, the job will also be done more. And if I reduce this hours per day wala number for the workers, the work done will also be less. Yani, if I ask the workers to work for 5 hours per day, let's say they will do certain amount of work. But if I ask them to do 8 hours per day, then they will do more work than what they are doing as of now, basically. So clearly, if I increase the rate, work done is also more increases. If I reduce the rate, work done also reduces. So that means they both are directly proportional. And when we say things are directly proportional, it means that their ratio remains the same or constant for that matter. So whatever is the ratio of work done should be the ratio of rate, or vice versa. Whatever is the ratio of rate should be the ratio of work done, which is going to be A is to B only. So these are the things again that you need to remember. And again, as I said, they are basis the same thing, the same relationship that we have seen earlier. So nothing super difficult or complicated as such, and these things are basis the common sense. The reason that I'm trying to explain in this manner, because this will help you to remember it for longer duration A, and B in a easier manner, because then you can not mess this up eventually. So that's the first part. The second part is something called as efficiency. Now efficiency is a simple thing which can be defined in general terms as work done per unit time. So in 1 unit of time, how much work is being done can be represented as the efficiency of the person or the machine or the worker, for example. Now this efficiency is basically defined or described in two ways, basically. Now one of the ways is something like this, which is given to us, which says if A is twice as good as workman as B, then we have to find out two things. What is the ratio of work done by A and B, and what is the ratio of time taken by A and B, basically. Now, here the thing is, let's imagine you are trying to explain this to a layman that A is twice as good as workman as B. Now, what does that supposed to mean for you? It simply means that whatever amount of work is B doing, A is doing double of that, basically. So let's say if B is doing 2 units of work, then A will do 4 units of work. If B is doing 5 units of work, A will do 10 units of work, and so on so forth. So if I want to find out the ratio of their work done, I can simply say that it is going to be 2 is to 1, basically. So whatever amount of work B does, A is going to do double of that. Now, next part is we have to find out the ratio of the time taken. Now, time is again work done and time ka relationship. So work done and time are inversely proportional. So whatever is the ratio of work done, inverse of that should be for time. So if the work done ka ratio is 2 is to 1, time ka ratio is 1 is to 2, for example. So obviously, and you can see that also that A is a better worker. So he is doing more job or more work in less time, and B is a slightly slower or the lazier worker, we can say probably, or less efficient worker probably, and then he's doing less time in less work in more time. That is the simple basic understanding behind this. Now, of course, what are the things that you need to remember here is that they can change this up. So, for example, they can say A is one third as good as workman as B. So from that statement, you need to figure out the work done ka ratio. And once you get the work done ka ratio, you inverse that and you get time ka ratio, because time and work done are inversely proportional to each other, basically. So that's the idea behind it. So this is one way of representing efficiency. The second way of representing efficiency can be in terms of percentages for that matter. So let's see what is the example. So the example is if A is 20% more efficient than B, and we have to find out same two things, the ratio of the work done and the ratio of the time. By now we know if we find out work done ratio, we just have to inverse it to get the time ka ratio. So again here there are multiple ways to look at it. Since the numbers are simpler, I will take also a very simple way to do that. So we can use method of base 100 because the percentage number is simple, which is 20%. If percentage number becomes complicated, we have to consider fractions wale methods that we have learned in percentages. So if you are not knowing what we are talking, please go back to those videos of percentages, introduction to percentages, and try and see these kinds of examples that we have discussed there, so that you get a hang of it. Basically, that is very very important. So they're saying A is 20% more efficient than B. So if I simply assume that, let's say B does 100 units of work, so A is doing 20% more efficient. So that means A will be doing 120 units of work. So that means their ratio of work done will be 120 is to 100, which can be further reduced by 20, and then it will be 6 is to 5 for that matter. And then the ratio of time taken will be inverse of that, which will be 5 is to 6. So this is how you will be able to figure it out. Suppose it would have been 20% less efficient, then A would have done 80 and B would have done 100 only. So the ratio of A and B would have been 4 is to 5, and so on and so forth. Work done, then time is obviously inverse of that. So that part is will always be there. So you will come to know from the language of the question, and you will be able to figure out what is supposed to be done and how it is supposed to be done basically. So that's the second way of representing efficiency. Then after this, there is one more point that you need to remember: the wages that are supposed to be distributed apparently, let's say to the daily workers or in general also. So these wages are normally distributed in the ratio of the work done and never in the ratio of the time taken. The logic is very very simple. If you start, matlab, think about this. If you start paying the workers basis the time taken, so for them in their head, there is a very simple relationship that more time is equal to more money. And then they will not complete their job on time. They will keep on extending it and taking more time and more time and more time. So ideally the logic is very simple. You are not supposed to pay them basis the time. You are always supposed to pay them basis the work done. So how much is the work, that will decide the payment, not the time. Your time can be anything, less time, more time, that is their concern. So that is the idea behind it. So remember that all these notes will help you to simplify few word problems wherein which the payment will be involved for the workers basically. Now moving on, let's do few questions and then we'll see the concepts of pipes and systems, and then we'll do uh, many questions of written work and pipes and systems, basically the varieties. So the first question is one of the very simplest question, and you can also do it without solving anything as a common sense perspective. So let's read that first. It says A can paint a wall in 8 hours working alone, whereas B can also paint the same wall in 8 hours working alone. If both of them decide to paint the wall together, in how many hours they will be able to do so? So this is hours. There is a small printing error, which is okay. So what are you understanding here? So A can paint the wall in 8 hours working alone. B can also paint the same wall in 8 hours working alone. So they both are doing the same work because they are painting the same wall, and also the time is same for both of them. So they are doing same work in same time. So what does that supposed to mean for you is that their efficiency of doing the work is same also. And now if they both decide to paint the wall together, obviously in 4 hours it will be done. Why so in the 4 hours? Because both of them can do it in 8 hours working alone, right? A and B. And similarly, if they decide to do it together, since their efficiency is same, so they will complete half of work. Now A will take 4 hours to complete the half, his half, and B will also take 4 hours to complete his half part of the job. So the work gets done in 4 hours basically. So that's the answer for the first question, which is 4 hours. Very simple, very straightforward. Work done is same, time is same, efficiency is same. The second question is something that we need to understand and cater to it properly. That is, let's read that. A can paint a wall in 8 hours working alone. B can also paint the same wall in 6 hours working alone. If both of them decide to paint the wall together, in how many days they will be able to do so? Now, in this particular question, lot of the people make a very very silly error, which is they will add the time 8 and 6 and they will do average of that, that is divided by 2, which comes out to be 14 divided by 2, which is 7 hours. But try and understand logically. B alone can paint the wall in 6 hours basically. So if they both are working together, obviously the answer has to be less than 6. It cannot be 7. So that's how you should come to know that it's not right and we have made the mistake. But the method that we are going to see is something that is very very important, because for almost 70-80% of the questions of written work and pipes and systems, this will be the initial calculation that we are going to see. But here you'll have to do something. We call it as LCM method though. So here you'll have to do something, that is you'll have to make sure that the work is same for both of them. So for example, they said that A is painting a wall in 8 hours working alone, and B also paint the same wall, and this part is very critical. So same wall, that means the work done is same, but obviously the time is different for both of them when they are individually working, and that is the meaning, that their efficiencies are different to work basically. So that's why the time is different, because work is same. So we call that as an LCM method. How do we do that? Very, very simple. What we will do is we'll assume that the LCM is for 8 and 6. Let me do it in a better way slightly so that you guys can understand. So let's plot the data first. So A can work in 8 hours working alone. B can do it in 6 hours working alone. Whatever is their work should be common to both of them, as we discussed, because they are painting the same wall. So we have to take LCM of both 8 and 6, and LCM of 8 and 6 is 24 units. Always you have to do this. Now let's find out the individual efficiencies of A and B. So A can paint the wall, that is A can do 24 units in 8 hours. So on a per hour basis, he'll be doing 3 units. 8 threes are 24. B can do it in but 6 hours only, 24 units. So B का efficiency हो जाएगा 4 unit per hour. 6 fours are 24. These are their individual efficiencies. Now what they decided to paint the wall together. So if they start working together, their combined efficiency will be 7 unit per hour. And at that combined efficiency, they are supposed to do 24 units of the work. So time is always work done divided by efficiency. So these many hours they will take, which is slightly more than 3 hours but less than 4 hours. Now one more challenge that you will have in this particular topic, that is converting these fractions into mixed fraction, and that normally only happens in written work. I have not seen that happening in any other topic as much as it happens in written work and pipes and systems. So let's also try to do that. So let's actually divide 24 by 7. So quotient is 3 because 7 threes are 21. Remainder is 3. So how do we write this in a mixed fraction format? So here there is a quotient, here there is a remainder, and here there is a divisor. So with that being said, it becomes 3 by 7 hours, for example. So obviously you need to look at the options first. If mixed fraction wala answer is there, then you'll have to also convert your answer. If it is not there, if 24 by 7 is there given already in the option, then obviously don't convert. Don't waste your time and just mark that and move on. So this is the way that we are going to look at majority of the question, which we call it as LCM method basically to do the questions. So that's your second question, which is related to written work. Now, moving on, as I said, we also have to see what is pipes and cisterns and what are the concepts that are related to that. So, there is one more extra thing that comes in pipes and cisterns, but we'll see that when we come to the questions part, not as of now. So they have given the ratio of the radius of the two taps is in the ratio 1 is to 2. And they want to find out two things, ratio of the output and the ratio of the time taken by two taps. So output is again simple, that is work done, and you will know work done and time are inversely proportional. Now, normally the taps that are there, they are in the circular shape, and hence they have given the radius ka ratio. When we calculate the output, output is work done, so tap is in the circular form. So whatever water that is coming out of it will also be in the shape of a circle only. So obviously we have to do area of circle. Area of circle, the formula that probably you would have done in the school is pi r square. So area of first tap is, we can say, pi r1 square. Area of second tap is, let's say, pi r2 square. And we have to take the ratio. So we'll also divide them. So pi gets cancelled. R1 square plus R2 square. Radius is given 1 and 2 respectively. So 1 ka square is 1, 2 ka square is 4. So I think the ratio of output should be 1 is to 4. This is the reason for that. And then ratio of the time. Time is inversely proportional to work done. So time ka ratio becomes 4 is to 1. So this is how you can understand, and you'll see that the philosophy is the same to solve the question. And as I said, one more extra thing, but we'll see that when we see the actual questions that are related to rate and work. So this is the way. Now, what we should be doing is trying to solve more questions so that we get that clarity, how to apply all these concepts that we have learned so far. So let's start with the questions. Here is the first one. As usual, I would request you all to pause this and then, of course, give it a go yourself and then see the solution. So the question is: a fort has a food for 80 men, which will last for 45 days, and 15 days later, reinforcement arrive, leaving the number of days that the food would last to only 20 days. What was the strength of the reinforcement? So that's what they are asking. Now, very simple thought process here, that people try and equate the values at day one, which is not the case because the reinforcement is not arriving on day one. The reinforcement is arriving 15 days later. So first we'll have to do the formula. The formula of work done that we know has three component: people, machine, and then rate and time. Here the rate is not given, but people and time is mentioned. So we can say that the fort has total food which will last for 80 men, and for 45 days it will last for, basically. That's what they have given. So this much food is there available in the fort as of now on day one, is what we can say. Then they are saying after 15 days reinforcements are coming, and obviously reinforcement is more number of people, and if more number of people will come, the food will get over early. Simple as that. But the point here is that the reinforcement is not arriving on day one, so we should not be comparing with this number. We should first take a stock of that scenario, that is 15 days later. Now assuming hypothetically that after 15 days reinforcement has not arrived, this is a hypothetical scenario, that reinforcement has not arrived after 15 days. So can we say that the same food will last for 80 men for 30 days, because 15 days have been passed from the 45 days basically. So if reinforcement would have not arrived, then the food will last for 80 men for 30 days after 15 days, continuing the same situation. But unfortunately, this is when the reinforcements arrive, and obviously, because of which the food is now going to last only for 20 days. So 10 days have been reduced because more people came, which is common sense. So we should be equating with this number because reinforcement arrived after 15 days. So reinforcement, the strength we do not know, so let's assume that is x. So now we have 80 plus x days, 80 original people and then x, that is the reinforcement that they have arrived, and this will last for 20 days. You solve this simple equation, you get your answer. 24 is 80, this is 120, 80 plus x is 120, obviously x has to be 40. So 40 men arrived extra as the reinforcement, which is the answer. What was the strength of the reinforcement? They said. So answer is 40. Basically. Option 3 for the first one. I hope you have understood. Let's do the second one. X can do a piece of work in 10 days working alone. Y can do it in 15 days working alone. Z can do it in 25 days working alone. How many days it will take for them to complete the work if three of them work together? Now, this is the very classic question that we have also seen in the concept. We just had two people, A and B. Here there are three people. So the process will remain same. So that means whatever is the work, it should be common to all three of them because they are doing the same work, and common as in it should be LCM of all three numbers, which is 10, 15 and 25. So LCM of 10, 15 and 25 is 150. So let's assume that the total work is 150 units. Now post we have done the total work, I hope you remember that we find out the individual efficiencies of everybody. So let's do that. Individual efficiency, individual efficiencies for these people. That is, X can do 150 in 10 days. So that means the efficiency of X per day will be 15 units. Y can do it in 15 days. So Y ka efficiency is 10 units. Z can do it in 25 days. So Z ka efficiency is 6 units per day. Now, if they all start working together, so their combined efficiency should be taken in consideration, which is the addition of all three, which is 31 units per day. And at that combined efficiency, they are going to do 150 units. So, how much time will be taken? So, clearly, time ka formula is work done divided by efficiency. So, 150 divided by 31. So, that's your answer for question number 2, which is answer option 1. Now here there is no need to do it in mixed fraction because the option is already present. Whenever required, we'll have to do that as well, basically. That's your second question. Question number 3. Tab A can fill a vessel in 12 hours. Tab B can fill it in 18 hours. While a drain pipe C can empty it in 24 hours. How much time will it take to fill the vessel if all three are operating simultaneously? Now, see, this is the new concept that I was talking about, which is related to pipes and systems. But first, let's try and understand the first line, which says tab A can fill a vessel in 12 hours working alone. Tab B can do it in 18 hours working alone. Now, when you read this kind of statement, don't you think it is as good as saying A अकेला काम करेगा तो 12 घंटे लगते हैं, B अकेला काम करेगा तो 18 घंटे लगते हैं? So because the thought process is the same, so the solving process is also gonna be the same. The only new thing that you have to understand is a concept of drain pipe. So try and understand the tap A and B are filling the vessel, whereas tap C is draining the vessel, it is emptying the vessel. So whatever calculations that are related to the drain pipe, we are supposed to take them as negative. That's the only new thing that you need to remember. Rest all will remain the same. So A can do it in 12 hours, B can do it in 18 hours, C can empty it in 24 hours. So minus we have to take. Capacity of the vessel should be combined to all three of them, that is LCM of all three of them, common of all three of them. So 12, 18, 24 ka LCM is 72. Now see, your numbers have to be good. Huh? You cannot struggle here to find out LCM. If you struggle there, then that's a problem. So make sure you are good with that process. Let's do the efficiency calculation. A can do 72 units in 12 hours, so the efficiency is 6 unit per hour. Then B can do it in 18 hours, so 4 unit per hour. C can do it in 24 hours, so 3 units per hour. But then negative 3 units because it is emptying the vessel. It is draining the vessel. Now, all three of them are working together or operating simultaneously. So their combined efficiency will be 7 unit per hour. I hope you understand that because A and B will fill 6 and 4 units, that is 10 units of plus that is coming in the vessel, whereas C is draining out 3 units every time. So the final net efficiency becomes 7 units. And again, we have to find out the time. Time is work done divided by efficiency. They're supposed to do 72 units and their combined efficiency is 7. So I think answer option 3 is the answer for question number 3, for example. This is the way we can solve that. Question number 4, it says X can do a piece of work in 10 units working alone. Y can do it in 15 days working alone. Z can do it in 25 days working alone. All three of them start the work on the first day, and after working for 2 days, X quits the job. After another 3 days, even Y quits the job. In how many days the job will be completed is what they are asking. Now, how do we do this? So the initial calculation will remain the same because it is exactly same as the second question. So work done should be common to all of them, that is 150 units. Then we will find out the efficiency. X ka efficiency was 15 units, Y ka was 10 units, and Z ka was 25 units per hour, per day, whatever, per day now. Then what has happened? All three started on day one. After working for 2 days, X quits. Now X ka efficiency is 15 units per day. He has worked for 2 days. So I hope you understand he'll be doing 30 units of work before leaving the job. Look at this language now. After another 3 days. So after X has quit after 2 days, after 3 more days, yani in short it becomes 5 days now in total. So Y has also quit. So Y is working for 5 days. Y ka efficiency was 10 unit. In 5 days he will be doing 50 units of work before going off. So we can say that X and Y both have completed 80 units of work before leaving the job. X has done 30 units, 15 units per day के हिसाब से for 2 days. Y has done 50 units, 10 units per day के हिसाब से 5 days. Now the remaining work, so 150 was the total supposed to be done. 80 is done by X and Y before quitting. Remaining 70 units now, Z alone have to do it because X and Y has left the job now. And how much time it will take? So Z ka efficiency is 6 unit per day. My bad, because he's taking 25 days to do 150, and in that time he has to do 70 units. So this much will be the time, which is around 11 point something. Only one option matches that, which is answer option first. 11 2 by 3, 11.66 days it will take for Z to complete the entire work, basically. So very uh, bad working style. But what I'm trying to tell you is that you just have to read it carefully and try and understand who has worked for how long and how much work they have done, and whatever is left over, who's gonna do that. So 70 units is left over and Z alone is gonna do that. So Z will take 70 divided by 6, which which is 11 2 by 3 days to complete the work, which is answer option 4. Sorry, answer option 1 for question number 4. And that's how you can do this particular question. Moving on, question number 5. It says X can do a piece of work in 15 days working alone. Y can do it in 25 days working alone. How many days will it take to complete the work if two of them work on alternate days? Now, very interesting this concept. You have not seen this before, that people are working on alternate days. This simply means that X will work on one day and Y will work on another day individually, and vice versa. Now, here comes the next important part that you need to remember going forward in such kinds of questions. That is, unfortunately, this means there are two possibilities that we can cater to. One possibility is where X starts on day one, and the second possibility is that Y starts on day one, and we have no clarity about it because they have not mentioned anything. So, unfortunately, we'll have to do it for both of the possibilities, and whichever answer option that is there present out of both the answers, we'll have to mark that answer as the final answer basically, and that's how we will be thinking about it. So if we think about this particular idea and how do we go about this, so let's do the initial calculation first. X can do it in 15 days, Y can do it in 25 days. So whatever work is supposed to be done, it is common for both of them. So it should be LCM of both of these numbers, common multiple of 15 and 25, which is obviously 75. So let's assume that. And then the efficiencies, the individual efficiencies, X can do 75 units in 15 days. So that means the efficiency of X is 5 unit per day. 15 5 is 75. And Y can do it in 25 days. So Y ka efficiency is 3 units per day. This is the original initial calculation. Now, as we discussed, we have to create two scenarios. Let's assume the first scenario, that X starts on day 1. So if X starts on day 1, then what will happen is that he will go and then he will do his 5 units and then come back. If Y starts on day 2, then I mean Y goes on day 2, then Y does 3 units and comes back. And then the cycle of 5 and 3 keeps on continuing. X 5 units, Y 3 units, and so on and so forth. Now think about this. Any two consecutive days that you will observe, always 8 units of work will be done. In every 2 days, basically. In every 2 days, 8 units of work will be done. So we were supposed to complete 75 units basically. We have to understand, in 2 days, 8 units of work is done. So any multiple of 8 which is closer to 75, obviously it is 72. So for completing 72 units, we will require 18 days, not 9 days, because 8 nines are 72. But in one day, 8 unit is not happening. In 2 days, 8 units is happening. So for 72 units, we'll have to do 18 days basically. And on 19th day, then on 19th day, who will go to the office? On 19th day, who will go to the office? Obviously, X will go to work because he has started on day 1. If X goes to the office, he is not supposed to do 5 units. He is only supposed to do 3 units now because total job was 75 units and 72 units is already done in 18 days. So only 3 units is left. But on 19th day, X is gonna go. And if X goes on 19th day, he has to simply do 3 units. And for doing those 3 units, he will not take the entire day. He will take only 3/5 of a day. So point is, if X starts on day 1, then the answer is 18 full days, and 19th day ka only 3/5 of a day is required. So 18 3 by 5 is the answer in the first scenario, basically. And once you understand this first scenario, the second scenario is very, very simple and will be running on the same background. So only part that will change is the last part. The rest everything will remain the same. We'll see how does that also happen. So let's take the second assumption that Y works on day 1. So if Y works on day 1, he will complete his 3 units and come back. Then in day 2, X goes, he does 5 units, comes back, and so on and so forth. The cycle keeps on running. Again, you'll observe the same pattern. For every 2 days, 8 units of work is done. And again, for 72 units, we'll require 18 days. And on 19th day now, who will go? So obviously Y will go now because he has started on day 1. And Y has to do 3 units because the remaining 3 units Y has to do. And Y ka efficiency, if you guys observe, it is 3 units per day. So that means to complete that remaining 3 units, Y will take entire 1 day if he goes on the 19th day. So this means in the second possibility, the answer is 19 days for that matter. So if Y starts on day 1, answer is 19 days. If X starts on day 1, the answer is 18 3 by 5 days. Now we have to see the option. The option has this answer, but we have to convert it. So 18 5 plus 3, which is 90 plus 3, which is 93 by 5 days. So 93 by 5 in mixed fraction can be written as this, 18 3 by 5. So this answer is there. So we'll also mark that answer, which is answer option 2 for example. So remember this idea, people, that is working on alternate days. So you'll have to assume both the scenarios, and whichever is the present scenario, you'll have to mark that. I hope you have understood. Let's look at the next one, sixth one. You and me can complete a job together in 30 hours. V and W can do it in 40 hours. And W and U can do it in 60 hours. In how many hours will W finish the work individually? So different variety again. So far we have seen only single people working. Right now they are working in pairs. So that's how first you understand that it's a different type. But the calculation and the thought process will remain the same because we have to find out W alone ka time. So let's do the initial working again. So UNV takes 30 hours, VNW 40 hours, WNU 60 hours. They are doing the same work. So it should be same for all of them, which should be LCM of 30, 40, 60, which is 120 as usual. And then let's find out the efficiencies. So UNV can do 30 hours can do 120 units in 30 hours. So their efficiency becomes 4 units per hour. For VNW, 120 units in 40 hours. So their efficiency becomes 3 unit per hour. And WNU 60 hours में 120 units. So 1 hour में 2 units. Now the problem is they are asking W alone ka time. So for that to happen, we should have W alone ka efficiency. Unfortunately, when we say UNV ka efficiency is 4, we do not know the breakup, whether it is 3 and 1 or 2 and 2 or 1.5, 2.5, whatever may be the case. So that's the thing. So how do we still do that? So see, there are now multiple approaches, and why the other core ideas are very important in such kind of scenarios. They are important. So you have basically three equations, and you have three unknowns. You can obviously simultaneously solve them and get your answer. That is one way to do that. But the easiest way to do that would have been you simply add both the equations. So if you add all three equations on both the sides, On the left side, you end up getting 2 times u plus 2 times v plus 2 times w. And on the right side, you end up getting 4 plus 3 plus 2, which is 9 basically. Now here, if you remember, we are supposed to find out w alone's efficiency. So u and v efficiency we know already, which is 4 units. All we have to do is substitute that, solve this equation, and you get W alone ka efficiency. So this is 8 plus 2W is 9. So this becomes 2W is 1. That means W is half. So W's efficiency is half, 0.5, 1 divided by 2 basically, units per hour. And at that efficiency, W wanted to do the job alone. So time. So time for W will be, W has to do 120 and at his efficiency, which is half. So clearly it is 240 hours he will require, which is answer option 2 according to me. That's how you get this particular answer. So combined efficiency, not a problem. Think like that and then proceed further to solve such kind of questions. That is different variety. Question number 6. Let's look at the next one, question number 7, which says A alone takes 3 days more to finish the job than A and B working together, and B alone takes 12 days more than A and B working together. Then how many days are required for A and B to finish the same job working together? Now, this is one of the very important types of question. There is a standard shortcut formula for such questions, but again, you'll have to remember the language, and that language has to be exactly the same way that it is given right now. Only thing that will change is the numbers, the values. So they have said A alone takes 3 days more to finish a certain job if A and B working together, which is very obvious because if they work together, they will take less time. And if the same job A is working alone, then he will take slightly more time. So that's what is given. A takes 3 days more than A and B working together. This part is important. Same data is given for B. B alone takes 12 days more than A and B working together. So if B does the same job alone, then he will take 12 days more than A and B working together. So A and B को जितना भी टाइम लगता था उससे 12 दिन ज्यादा लगेंगे B अकेले को सेम काम करने के लिए, और A अकेले को 3 दिन लगेंगे सेम काम करने के लिए, अकेले करना है तो, which is very obvious. And now they are asking how many days are required for A and B to finish the same job working together. Now, this is the point that you need to remember. If something like this is given and they ask the together wala time, what you simply have to do is whatever is the extra time of A and B, you have to multiply them. So A ka extra time tha 3, B ka extra time tha 12, we have to multiply them, which is 36, 3 into 12, and you have to take root of that. So 36 ka root is 6. So answer option 3 is your answer. That's a shortcut formula to do that. You can remember this, but you'll have to remember the language and the type of the question, and then you can do this in 5 seconds, 10 seconds, 30 seconds, whatever. There is a proof why we do this, why we take this answer. So I will also give you the mathematical proof for that, why we do this, what we have done right now as a shortcut. Nobody does that though, I mean the longer way, but we'll do the explanation for the proof also, so that you know that this is how it came. So to do the calculation, let's assume the data. Suppose both of them working together are taking x days, and we have assumed that A takes a number of days more than x because x is their combined time, and we know the value of A is 3 for us because A takes 3 days more. Let's assume B takes B days more than x, so for us value of small b is 12. Also, let's assume that the total work is 1 unit. Let's find out the individual efficiency. both of them working together taking x days to complete one unit. So their per day ka efficiency is 1 by x. Then A ka, I hope you understand, A ka total time वैसे is x plus A and B ka total time is x plus B. So the efficiency will be 1 upon x plus A for A, and for B it will be 1 upon x plus B for B. Simple common sense. On the left side, if we add these two, we should get this one. So on the right side also, if we add these two, we should get this one. This is what has happened there. 1 upon x is equal to 1 upon x plus A plus 1 upon x plus B. You solve this, you simplify this, you calculate this further, you get this relationship, and that means x was the combined time, if you remember, and A and B are the extra times that A and B has taken. So we are multiplying them and we are gonna take the square. So that's the justification that why we do what we do. But henceforth, if something like this comes, you should be doing directly the shortcut way that we have explored basically to get the answer in a much faster manner than this entire solving process. For example, then question number 8, classic ratio question, which says three men and five women together can complete a certain job in 14 days, while two men and five women together can complete the same job in 18 days. Now, same job they have said, so we'll equate three men, five women can together complete the same job in 14 days. Same job, two men and five women can do it in 18 days. In how many days will nine men and five women will complete a job thrice as big as the one mentioned above? So nine men and five women can complete the same job in how many days? X days. But that job is three times as mentioned one above. Now it can be any one of these numbers and both will give you the answer. But the problem here is we have two variables. So what we'll try to do is we'll try to get a relationship between number of men and number of women first, and then we'll try to substitute that. So let's start solving this one. So this is 42 men plus 70 women. This is 36 men and 90 women. If you multiply by 18 and 14 respectively. Let's take the men here. So 42 minus 36 is 6 men. Women goes there. 90 minus 70 is 20. If we reduce this further, we get 3 men is equal to 10 women. If we reduce. Now what has happened is we have found out a relationship between number of men and number of women, and looking at that relationship, I think it is viable for us to substitute the left hand side वाला part here, because three men के जगह पे हम directly 10 women replace कर पाएंगे from the relationship. So hence I am substituting the left side वाला part and nothing else, not the right side वाला part, because that calculation will become complicated, which unnecessarily increases your headache. So yeah, now solving this equation, the reason is we have got this relationship 3 men is equal to 10 women. So 9 men, so 3 threes are 9, so 10 threes are 30 women. And then again, 3 men is 10 women. We already know that from the calculation. So let's do that. 30 plus 30, 30 plus 5, 35 women into x is equal to, this is 3 into 10 plus 5, 15 women into 14. Women is cancelled. X is 3 into 15 into 14 upon 35. Let's do the calculation. 7 5s are, 7 2s are, 5 3s are, 3 into 3 into 2, 9 into 2, which is 18 days, which is answer option 1. So 18 days will be required to complete this job in this same particular manner. So we had two variables, men and women. So we had to convert either men into women or women into men using the relationship. And then while also substituting, it will make a little bit simpler for you if you can do the right amount of calculation. Basically. This is how we do that. So this is question number 8 for you guys. Let's do question number 9, which is two pipes M&N can fill a tank in 16 minutes and 20 minutes respectively if both the pipes are opened simultaneously. After how much time M should be closed so that the tank is full in 10 minutes? Now, this is one of the most easiest questions of this entire handout. You can do this orally also, provided you realize what is happening. And for that, this last part is very critical. After how much time M should be closed so that the tank is full in 10 minutes? So, if we are closing M, that means for this 10 minutes, which pipe is on? Obviously, N is on for 10 minutes. We know from the data, N alone can fill the tank in 20 minutes entirely. But N is on for 10 minutes. So in 20 minutes, he can do the fill the tank completely. So in 10 minutes, he'll do half. And obviously, the remaining half, who has to do? M has to do. Now look at M ka data. M alone can do it in 16 minutes, the whole tank. But he has to do only half. So for 16 minutes, he can do full. So the half can be done in 8 minutes, which is answer option 3. So that's it. This is your ninth question. But of course, let's do it from the whole LCM aspect also. So LCM will be, that is the vessel capacity should be common for both 16 and 20, that is MNN, which is 80 units. Let's do the efficiency calculation. M can do 80 units in 16 minutes. So 16 fives are, and then 20 fours are. So M ka efficiency is 5 units per minute. N ka efficiency is 4 units per minute. They've said that the tank is full in 10 minutes and M should be closed. So for 10 minutes, N is on basically. So N ka efficiency is 4 units. In 10 minutes, he'll be doing 40 units out of 80. The remaining 40 has to be done by M. M ka efficiency is 5 units. So to do the 40, he will take only 8 minutes basically. But obviously, think that smarter way also that we discussed. If N works for half the time, M should also work for half the time. So you would have got that orally again without doing anything else fancy. So you need to understand such approaches also because such kind of questions will be done then very quickly and you can utilize your time smartly in some complicated questions where it is genuinely required for you to spend more time. So this was the second last question. Let's do the next one, the last one, which says, good question, which says a tank has a leak at the bottom that can empty the entire tank in 4 hours. Okay. And then the tank is entirely full and a tap that admits 5 liters per minute is turned on. And as a result, the tank now takes 8 hours to be emptied. Find the capacity of the tank, is what they are saying. See, here what is happening is if only the leak is on, the tank is emptying in 4 hours. But along with the leak, if we run a tap, which is also putting some water inside continuously, they have given that speed 5 liters per minute. Then still the leak is able to empty the tank, but now it takes obviously more time. Instead of 4 hours, it takes now 8 hours to be emptied. So that's the data. So in any case, the vessel is getting emptied. So let's formulate that. Leak only leak 4 hours में empty हो रहा है. लीक प्लस टैप 8 आवर्स में एम्प्टी हो रहा है. LCM method. So 4 and 8 का LCM, the capacity is suppose 8 units, 8 liters. Let's find out the efficiencies. सिर्फ लीक को 8 लीटर करने के लिए एम्प्टी 4 आवर्स लग रहे हैं. सो ऑब्वियसली उसका स्पीड होगा 2 लीटर्स पर आवर. एंड लीक और टैप को 8 आवर्स लग रहे हैं 8 लीटर्स एम्प्टी करने के लिए. सो उनका स्पीड होगा 1 यूनिट 1 लीटर पर आवर की स्पीड से एम्प्टी कर रहे हैं. बट एम्प्टी तो हो ही रहा है. नाउ दिस इज वेयर इंपॉर्टेंट पार्ट यू नीड टू रिमेंबर, दैट इज in both cases the vessel is getting emptied. Now we know the leak capacity is 2 units. We don't know the capacity of tap, suppose x, and it is minus 1 the whole total. Mathematically speaking, purely minus 2 में क्या ऐसा ऐड होना चाहिए ताकि आंसर minus 1 आ जाए, तो obviously answer should be 1. And this means the tap का capacity is 1 liter per hour and it is positive because it is filling the vessel. सो टाइम क्या होगा, टैप को अगर वो 8 लीटर भरना है एंड उसका स्पीड है 1 लीटर पर आवर, तो ऑब्वियसली उसको 8 आवर्स लग जाएंगे भरने के लिए ये वेसल को, अकॉर्डिंग टू अस बेसिकली, बिकॉज टैप का कैपेसिटी आया 1 लीटर बेसिकली. -2 + 1 इज -1 एंड 1 लीटर के हिसाब से 8 लीटर भरने के लिए 8 आवर्स लगेंगे 1 लीटर पर आवर के हिसाब से. Now this is all our data. We have to now look at their data because their tap ka speed is not 1 liter per hour. They have given it to be 5 liter per minute. So their original tap is actually doing 5 liter per minute, and we said it is taking 8 hours. So we'll have to do the calculation for that. So 8 hours is these many minutes. And 1 minute में 5 liter. So in these many minutes, another 5 liter should be multiplied. So 48 into 5, I think 2400 liter is the capacity of the vessel, basically, which is answer option 3 for that matter. This is how we can solve this particular question. Yes, 2400 liters. Answer option 3. So we had found out the capacity of the tap to fill, which is 1 liter per hour according to us, and to fill 8 liters it will take 8 hours. But the original tap that they have given in the data, it doesn't do 1 liter per hour. It does 5 liter per minute. So 8 hours converted to minute is 480 minutes, and then 1 minute में 5 liters. So 480 minutes में how many liters, which is 2400 liters, is the capacity of the vessel basically. So that's how the answer comes. So folks, we are done with written work. Go through this all over again. If you still have any questions, do let us know. We'll be happy to help you guys. So we are done for today. Thank you so much. Have a great day.